So, brief introduction about what is the AWS code pipeline. So basically, the code pipeline helps us in automate the build, test, and deploy phases of our release process every time there is a code change. So basically, if we make any change into the source code and we commit that change, and then it will automatically will be built and released, will be deployed. So we don't have to manually test that code, or we don't have to manually deploy that code. And that will be done automatic. We just need to make the change and commit that change. So that's the very high level information regarding what is the code pipeline. So basically what happens is the source comes from the AWS code commit. It can and then the build and the staging is done through the AWS code build. So basically that will test the code if there's any errors or whatever unit tests we have gotten into it. And the production, basically that's the last part, which is the AWS code deploy, and that will be used to deploy the code. So also instead of using code commit, we can also use the GitHub. The code commit can easily be connected to the GitHub, so that if we make any change in the GitHub, or like we make any commit, then it will be automatically reflected in the code commit, and then uh, that will go through the entire process. So basically, this entire thing is the code pipeline. So so basically, we make any change, we make a change in the source code, and we commit that change, and then everything happens automatic after that. So build, staging, and production, everything happens automatic. And this entire process is called AWS Code Pipeline.
The AWS Code Commit service is the first inside of the Code Pipeline service, and it creates a secure repository for sharing code in the cloud. So really, what does that mean? It's a fully managed source control service using Git as its backbone. So if you're familiar with GitHub, this is AWS's version of GitHub, basically. What are the benefits? High availability and security of your code. It also prevents the need to scale source control servers, and you can store anything with no size limits. Yeah. So what does this service actually look like inside of the AWS console? Where here's an example where I'm in the overall code pipeline developer tools AWS console, but a part of it is the code commit console. Here we can see I have repositories, and I've created this repository called the Steam Community Bot, which is an example application which we'll be using throughout this tutorial. This is an example though. This here has been created already, and you can see it actually stores code and files related to this application. It also has the notion of branches, just like any other Git repository, and can be cloned using any of the normal protocols to do so. To get started, you can go back to repositories, create a repository, and it's pretty straightforward. You basically can add tags if you want, but you pretty much give it a name, and it gives you an empty Git repository that you can then clone or commit to begin with.
So after the AWS code commit, the next step is the code build. So basically, in short, it's a continuous integration service that compiles the source code, runs the tests, and produces software packages that are ready to deploy. Um, Also, if there is, so let's say, for example, um, we make a change in the source code, and that change is committed. So the AWS code commit will run, and then the AWS code build will run. Let's say the change that we made in the source code results in errors, then the code build will fail, which means it will not initiate the code deploy. So the pipeline will make sure that that change that we made in a source code resulted in the errors is not transferred to the code deploy. So the code build will basically run the test, make sure that our source code compiles and it is good to go. If it is not, it will not let the code deploy to start. It has many benefits. The one is the fully managed and scalable build service. So Um, from the scalable, it means that we don't need to set up the processors, like processing power or the memory. That's done automatic. Depending on how the build is, like if the build is very heavy, it takes it's more process, like takes more memory or the processing power. It will be automatically adjusted to that. So, and again, it's pay as you go. So basically, um, when we hit the bullet button, it bullets it, and then that's the all the amount that we will be charged. So, um, and again, that's so it's very so for further information like the documents and about the code bullet can be found on the further info. Now I'm going to give you a demo. So we first go to the code bullet. So we go to the code bullet, and this will take to us to its like homepage, and from there we can click on create the bullet project. We can give it a name, and in the source, so we can select what from where our code will be coming from. It is S3, code commit, GitHub, or whatever. In the code pipeline, we will definitely use the code commit, but since it's I'm just giving a test mode just for the code bullet, so I will be using Amazon S3. In the bucket, we can choose whatever our bucket, and for the object key, so basically what's the zip file, and here I have the archive.zip. That is the what was the default name. The next is we keep the other things default. We gonna use the Linux. We're gonna use the standard. It's preferred to probably use the latest version, and we keep the other information default. So use the build spec file. So this the YML file is an important one because this is where what the code bullet will use, like what it needs. So like in order to run that test, and we also have the documentation regarding the bullet spec file, and there are many examples. It also goes into very detail about like what each thing, what each variables and they all mean, and then also gives the examples. So we have examples like this one, and basically the examples are divided. So like here is the what's the version name, and then we have different like phases like install phase, pre-build phase, during the build, and the post build. So these are like the different phases, and we basically do whatever we need to do here and regarding an application. And so that's the bullet spec file, which is pretty important. So I'm gonna show you that just after I finish this setting up. So the other information, the artifacts, the other output, we're gonna go into the Amazon. We're gonna output that into the Amazon. So this is the bucket. We keep other information default. We hit on create bullet project. So basically, as I said, this file, and this file basically contains um, these files. There's a build spec, main, test main, and requirements. So let me show you the build spec. So the build spec, basically, I have kept it simple. So basically, first the version of the YML file, and the next one is the install. So we're gonna use the Python because it's the Python application, Python project. So we're gonna install the Python 3.7 version. Or and the next is the before the pre-build. So before we start the build, we need to install some libraries into it, and that libraries are, so I'm gonna install it here, and they're located inside the requirement text, and these are the libraries that need to be installed so that our main function can run without the problem. And then we do that, and here before the build and during the build, so we run, and then after the build we run the unit test. So here we can see there are two files, main and test main. So the main is basically, this is our file that we want to test. It has the many functions like the get latest announcement and get the community name. So it's like two functions. And we want to test that. And so we have test main here, and so we run. So we have two testers. Um, so just in the meantime, I think I will be good at if I run this one. So where is it? So this is the test project, right? That we just made it. I'm gonna start this one. So it's gonna go into the different phases, submitted, queued, and the next one, and in that meantime, it will take some time, like a minute or so, to do this one. So in that meantime, I will explain this. So it has, so the test main, we import the unit test, and we basically test this two functions: get the latest announcement and get the community name. So basically, it will be tested, and we're gonna return. If it's all good, we will return good, and if it's not, then it will return an error. And okay, so yeah, so it's still running. Let's go to the build log. On the build logs, you can see it's running different. So first, it's like installing the version Python version 3.7, and it's also installing the different libraries that we need. Here are the tests. So it says they ran two tests in this many seconds. Results are okay. So this is what the test 2 is outputting, and test 1 is outputting. And so this one is the test 2, this one is the test 1, and they are outputting something which I like printed, and that's what they are printing. And since they did not, since the self-result was all they returned all good, and so that's why the test has succeeded. So when this code build is we put this into the pipeline, then whatever the change that we made in the code commit, then this code build will automatically run that test cases and make sure that the changes that we made are okay, and then the next part will be code deploy. So this is the one part that of the code pipeline.
The final service composing the AWS Code Pipeline service is AWS Code Deploy. It automates code deployments in order to maintain application uptime. So what is it? It is a deployment service that automates software deployments to compute services such as Amazon's EC2, Lambda, or your on-premises server. What are the benefits here? It actually automates deployments so you don't have to have any downtime of your applications running in the cloud. You have centralized control to distribute deployment, so you can essentially, deploy a new patch to every single current running instance of your application. So you basically. Okay, now here's a demonstration of the Code Deploy service. So again, we can see we're looking at the AWS Code Deploy service within scope of the developer tools. And we have a few options here. So to begin with, we need to actually make an application. So for our demonstration here, we'll be using an already made application and focusing on some of the key settings that need to be made for this application. So again, this Team Community Bot app, we'll click on it so we can see that this app has already been made. Its compute platform is EC2 on-prem, and it already is assigned in a deployment group. So the deployment group actually specifies how this application shall be deployed and actually what gets deployed, and so we'll dive in here. Okay, so now we're looking at the deployment group for this bot. We're going to go to edit to kind of look a little bit deeper. So we can see the application name. We're going to deploy it on EC2 or on-prem. And we're going to give the deployment a name, so it's given the community bot deployment group. The role that's needed is the code deploy role. This essentially allows the instances of EC2 to be able to actually run and connect to the deployment, the AWS Code Deploy service. Okay, the deployment type. So we have two options. We can do in place, which essentially takes down any instances of our running application and then restarts them with any new updates. Whereas blue-green, essentially you can start up a new application, and then only once that new application has been registered and verified to be working, you take down the old one. So we'll just do in place for now since it's simple. And then we have the environment configuration. So here, the environment configuration selects kind of how the application is deployed and onto what it is. So here where you're selecting the Amazon EC2 instance, and here we need to specify what instance of EC2 do we want, what's the configuration of that virtual machine. And here we've specified, okay, we want to use a group of instances called Steam Community Bot Pipeline Demo name. So this means that any instance that's currently running in EC2 under my account that has the tag Steam Community Bot Pipeline Demo will get this deployment. So let's actually go look at how we set that instance up before we move on. Okay, so I've switched over to the EC2 AWS service now, and I'm currently looking at the running instances that I have. So as you can see, I already have an instance running called Steam Community Bot Pipeline Demo. It has some settings, but maybe let's go a little bit into detail and replicate what was done there. So first of all, when we select EC2, I'm just using the typical Amazon Linux version that is suggested by AWS. There's some basic configuration for this virtual machine before it gets booted, so we're just going to select the free T2 micro storage that's connected to it. We want one instance. We also can select, we want to enable it to have a public IP address. Then there's options that we can use, but we're not going to specify any of those. We're going to focus on this advanced setting here. So the advanced setting actually is really quite important. This user data actually is what runs or what can run at the beginning of the launch of this instance. So when this virtual machine boots, basically what happens. And so we've actually set up some instances already, but we have an example script here that we will take and we can copy in. We can also paste as a file. But the idea is that we're going to be essentially installing some needed tools, so Ruby, the AWS CLI, and Python. And then there's also, here we're manually installing the AWS Code Deploy tools, changing it to executable, and then installing it. So this way, when the instance actually begins, we actually have the ability to connect this to the AWS Code Deploy service. Without this installation, this instance wouldn't be able to talk to the AWS Code Deploy very well. Okay, continuing on, we can review and add some storage. We won't be doing that here for now. And then we add tags. So this is actually the key point to link the Code Deploy service to the instance. So again, similar as was before, we used code, and we can now type in Steam Community Bot Pipeline Demo. Security group, we can connect to it using SSH. So I can say, hey, I can connect to this running virtual machine with my IP address. You can also do HTTP and things like this if you have a running web service, but because our application is just Python, we only need console access, so I can remove that. We can review and launch it and hit launch. I won't do that here, I'll just be using the already running one. Okay, now back to editing the deployment group. So where we left off was that we were setting up the EC2 instance, so we've now specified that we know what instance we want to deploy this application to. So the deployment settings is the next option here. This specifies how you want to roll out your changes. If you want to change the application and update it on every running instance all at once, or if you want to do it in a particular sequence if you have multiple instances running your application. You can also enable a load balancer, but we won't be doing that here. And we won't be using any advanced options, so we'll just hit cancel for now. Let's go back to our deployment group. Okay, so now what we can do is we can actually deploy this. So what are we doing? We're selecting the deployment group we want for this deployment that we've already made. And then we select what do we want to deploy and what version of it. So here we have two options. We have an application stored in Amazon S3 or an application stored in Github. So you basically store what code you want to put onto the instance that's already been started. One interesting thing here is that the code commit service provided by AWS actually is not supported within the deployment console for some reason. However, it is when you use CodePipeline. So I actually won't be creating a deployment right now using this. I'll be using CodePipeline in a bit. But I'll show you what a successful deployment actually looks like if we were to able to select code commit here. There are a few other options, so you can select how your deployment fails if something goes wrong, if you want to overwrite content or retain it. But basically, if I were to hit this deployment, what would happen is the code that I selected here gets directly placed into the running instance. So I'll show you that now. Okay, so now I want to show you what a successful deployment looks like. So we can see we have our instance running in EC2. In order to show you, I need to connect to it, so I'll do so using the SSH command with this .pem folder, which I downloaded at the first time that I set it up. You can see I have that pem folder in my downloads folder, and now I'm going to connect. So now I have a shell of the running virtual machine that I can connect to. And in the home folder of this EC2 user, we can see we have that leftover install file that we set up or we wanted to download and run when we first booted the virtual machine. And we also can see we have the Steam community bot folder. And that's been copied over. So how did that happen? How is that deployment specified? So that's actually shown in this appspec.yaml file. So this appspec.yaml file is very important. It specifies everything about the deployment that should occur. So when the deployment occurs, it looks first for an appspec.yaml, and then it will basically dictate how to run things in the virtual machine using this file. So the first step is the files that need to be there. So first we're taking the source, so the entire Steam community bot repository that we have, and we're going to paste it directly into the home folder called Steam community bot here. And then we have these things called hooks. I'll explain those in a second in detail, but essentially these are stages at each step of the deployment that happen, and they dictate what to happen. So here we have a location of a script, who to run it as, and a certain timeout for stopping the existing application and starting a new one. And that script is pretty much simply just creating a Python virtual environment and then copying over the latest service version so you can run as a Linux service. It's restarting the daemon for services on Linux, and then it's essentially running this service that's created that is defined within scope of this repository here. Okay, so the key takeaway here is that the whole repository of Steam Community Bot has been posted directly into this virtual machine at this location. And you can see the top level files include the app spec, which are specified. And we could even prove that the system is actually running correctly, or this service that we started is running correctly by checking on the service that's defined within the scope of the repository, and we can see it's active and was loaded properly. Okay, so to try and review what was done there, first we had to create a code deploy project. So the process of creation included creating an application and then a deployment group. That deployment group specified what application to deploy and where it should be deployed, as well as the order of deployment. And then the deployment of itself actually needed to be created, which essentially had the ability to copy a repository into the virtual machine as defined in an appspec.yaml file. So that must be in the root of the repository, and it specifies what to do at each stage of the deployment. So these deployment stages, actually there can be many of them. We saw that in the app spec, but we only use two, the application stop and start. But the idea is that these are the sequences of events that happened when you deploy something. So the first thing is to actually stop the app, then to download the new one, install the new one, but obviously decrypting or unzipping it first if you need to in the before install. Installing it is moving source into the target directory. Then the install is actually configuring the application to run, like what do you need to do before you start it, and then you actually start it using the application start step. And then finally the validate service verifies that deployment was successful or not. And that summarizes code deploy. Okay, so now putting it all together, what is AWS CodePipeline? It is the sequence of these three services. So here's a quick example that we have for the Steam Community Bot pipeline. We have source, which gets checked out. We have a build stage that runs the test to ensure that everything's still working properly. And then we have deploy step that actually gets deployed onto our running application. So I'll quickly show a demonstration of the running application in its current state, then make a change, and then show its state afterwards. Okay, so here's the example that we'll be going through. So we have a Steam Community Bot pipeline that essentially connects some source to a build stage and to a deploy stage. So what we have here is every time that a certain change in the source gets made from AWS code commit, it triggers a build in AWS code build, which if successful calls AWS code deploy. And so those are the example steps that we have. We can edit each individual stage here. So if we edit the source provider, we can see we have the Steam Community Bot repository from AWS code commit. We then use the detection from AWS CodePipeline, and we're using a bunch of defaults provided by them. We can edit the build stage. So here we have the community bot build action. So this occurs with the help of AWS Code Build using the Steam Community Bot build project that was set up earlier. And then finally, along the same line of process, we have a deploy action, which gets deployed by AWS Code Deploy. Oops. The source artifacts are provided for the Steam Community Bot app, which gets deployed using the deployment group we had set up. Okay, now to show you the application that's running, it's currently running on the AWS instance, but it's actually a Discord bot, which we can tag, and we can see a response. So we'll call help, and we can see this Discord bot has responded with help. So now what we're going to do is we're going to go into our repository source, and we'll find the help message, and we're going to change it to hello EC 520.428. I will then commit this. I will add this first to commit changed help message. Okay, now I will push this and we'll watch it happen in real time. Okay, now we can see that the code pipeline has actually begun with that commit automatically because we have a source setup where it will basically run every time that a new change has been made to the master branch. We see that that has been successful. We found the new version. Now we've triggered the build stage, so now we're running tests. This will take a minute. Okay, now we see the build stage is completed, and now the deploy is actually taking effect. Okay, and we can see that deploy has succeeded successfully here, even though this is not updating. And now we can prove that we've changed the bot itself in the deployment. We will run the same exact command, and we will see hello EC 528 and 428. Yeah, so essentially what we've done is we've been able to make a commit on the master branch of a repository. The tests get automatically ran, and assuming they all pass, the bot gets automatically updated in the Amazon EC2 virtual machine. Yep. Okay, so let's dive a little bit deeper into each stage. So we can see here we've just got a checkout notified from code commit for this newest commit, which we can see here occurs right here, 4F056, which we can see is right there. Once that commit is made onto master branch, it triggers the bot build stage. We can see some details of that output here, but the essential idea is that we have two tests ran. So we ran two tests and they were successful. So we then triggered the final deploy stage, and we can go look at some details of this deployment. Let's find that. Yeah, let's go to view event. So here we can see the deployment itself was of the Steam Community Bot using the deployment group, Steam Community Bot deployment group. And then for each step that we had mentioned earlier is actually being checked. So each step was executed, and there was some status for each of it, what we were able to successfully stop and then start the application, which we can see took about 2 seconds. But we've been able to successfully deploy the application automatically just from a single commit on the repository's master branch. Okay, so in summary again, we've had a look at the whole entire pipeline offered by AWS CodePipeline, first starting with AWS Code Commit for source, which we could show we've committed to. We then showed that AWS Code Build can be used to build and start the deployment of the application once tests are approved. We could have the manual approval, however, we've skipped that step here because we just automatically assume that when the builds pass, that there's no problems and we can deploy. And then we finally use AWS Code Deploy to deploy the new application to our production server, and we can directly see that the new version of the bot is running on the Discord server, and so we can continue this loop all the time. And this entire process provided by AWS is called the AWS Code Pipeline, which we have presented here. So thank you for listening. I hope you have enjoyed. Take care. Bye.